Now, let's really get into adding vectors now. So let's take vector A and vector B, and our directions might say find A plus B. So essentially the way to do that is when I have these two vectors this way, I draw this parallelogram to complete. Oops. Okay, there it is. So, and then what I can do is I just draw the line completing those two. This is called the parallelogram method. And then essentially this is what I have as my new vector. Oops, I'll leave that there. So this is what my vector would be. This vector right here would be A plus B. So that's essentially how it works. I can create a parallelogram. Now notice I have them tail to tail over here. Or, yeah, tail to tail. They call the tail the initial point, just so you know. And they call the arrow here, they call that the head. So it's another terminology I can put in with this as well, the tail and the head. So the tail is the initial point, and the head is the arrow. Okay, so anyways, that's how I can add using a parallelogram. Now there's also another method we can use. So if I had these two vectors again, the way I could add it is simply, I would take the tail here of B here, and I would just place it up here and then let the rest of the vector kind of just go along with it. And watch what happens. So here we go. And then essentially what we do after we do this is we just draw the vector in. And now notice what I did here. I put the tail of the second one on the head of the first one. If you notice what I did there. And then what I'm going to do now is I'm just going to draw the vector from the tail of the first one all the way to the head of the second one. And that's going to be my new vector. Now if you notice, if I put those two vectors side by side, we'll see that they're exactly the same vector. Now again, they're equal vectors as long as they're the same direction and same magnitude. And don't forget, vectors are just directed line segments. So that means they have a beginning and they have an end. And as you can see, if I just kind of follow these lines all the way across, we'll see that's the start. We'll see that's the end. And then if we count all those, we'll see that it's 1, 2, 3, 4, 5, 6, 7, 8, 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. That one go 10? 1, 2, 3, 4, 5, 6, 7, 8, 9. That's also 9 across. I just miscounted. So we can see that they're going to be equal vectors because they're in the same direction. They have the same measurements. And the magnitude's the same on these. So we see that they're the same vector. So it's just two ways to kind of just do the same thing. So we have the parallelogram way, which is this one here. And then we also have the tip to tail is what they call it, because it's the tip of the first one to the tail of the second. So there we go. There's just the two different ways in which to add vectors. Now let's talk about A minus B. So really the way I look at this is really A plus a negative B. So essentially all I do is I take B and I go in the other direction. 1, 2, 3, 4, 5, 6. So it should be about that long. Oops, I went too far. It seemed a little long, so let me go back one. Okay. Is that right? should be right there. All right, so there it is. So that's negative b. So now essentially what that means is I'm just going to add those. So I'm going to take this way, and I'm going to take this way. And I want to make sure I get the same angle here. Now I'm using the parallelogram process if you hadn't noticed. And there it is. Now this angle, this vector, not angle, here is going to be my vector a minus b. So a minus b is going to be right here. All right, so there it is. That's my answer for this one. So on the next video, what we're going to do is we're just going to put some actual values to all of these. But we initially had to understand how we could actually add and subtract vectors.